Hey guys, welcome back to Chilifili, and in today's video we are going to see what is simple linear regression and how we can implement it using Python. And in this video we are not going to use Scikit-Learn library to calculate the slope and intercept to find out our regression line, but instead we will build our own function that will calculate slope and intercept, and then we can use it for our regression line. So before all of that, we need to know what is a simple linear regression. So simple linear regression is a statistical method that allows us to summarize and study the relationship between two continuous variables. One variable is regarded as independent variable and the other one is regarded as dependent variable. And our goal is to find the value of dependent variable based on the value of independent variable. So let's take an example here. Okay, here is an example. Suppose you want to sell your house, but you don't know at which price you should sell your house. So here is a problem that if you set the selling price of your house too high, then probably no one is going to buy it. And if you set the selling price too low, then you might face financial loss. So what you are going to do is you go to your neighbors and find out the data such as area and selling price of their houses. So suppose there are two houses in your neighborhood, house A and house B, and you find out the area in square feet and prices in dollars for both of these houses. Okay, then we can plot our data on a scatter plot, or you can say coordinate plane, with area as an x-axis and price of the house as y-axis. And here we have plotted our data. You can see it. The first data point is 1500 and $150,000, and the second one is 2500 square feet and $300,000. Okay, so here is what we need to do. We need to find the price of our house, which is an area of 1800. Okay, so we all know the area of straight line is y equals to mx plus b, where m is the slope of the line, b is the y-intercept of the line, and x and y are the coordinate points of our data set. Okay, so here we have m as slope and x we are taking as area of our house, and we will get y as the predicted selling price of our house. So we need to find m and b for to find the predicted selling price for our house, as we already have area. Okay, so to find the slope of the line, we have an equation called y2 minus y1 divided by x2 minus x1, where x1 y1 is the coordinate point and x2 y2 are also coordinate point. Okay, so here is some basics of coordinate geometry if you want to brush it up. Okay, we always look from left to right in the coordinate plane to name the points. Okay, so while looking from left to right in a coordinate plane, which point comes first, we name it x1 y1, and the point that comes after that we name it x2 y2. Okay, and horizontal lines have slope of 0, vertical lines have infinite slope, and if the y coordinate of the second point is greater than the y coordinate of the first point, then the line has a positive slope, else the line has negative slope. And points at the same vertical distance from x-axis have same y-coordinate, and points at the same vertical distance from y-axis have the same x-coordinate. But I think you already know all this information. So let's go ahead. So here we have to find the slope of the line with our points called x1 y1 and x2 y2. So here we can find our slope, and you can see that we have plotted the value of y2 minus y1 divided by x2 minus x1. So we will get a slope of our line as 150. Now all we need to find the y-intercept of our line. Okay, to find the y-intercept of our line, we have y minus mx. We can derive it from our main equation. Okay, so we have y-coordinate, slope of our line, and x-coordinate, and we will get our y-intercept as minus 75,000. Okay, so here you can take x coordinate as 1500 and y coordinate is $150,000 also, and you will get the same result as this. Okay, so now we have our finalized equation for our slope, that is 150x minus 75,000, where x is the area of our house and y is the predicted selling price. So we need to find the selling price of our house, which is an area of 1800 square feet. So let's plug it in. So when we plug it 1800 in place of x, then we will get a predicted selling price of the house as $195,000. That's a pretty good guess, I think. Okay, so in real world data, we don't generally see only two data points. We have millions of data points from which we have to conclude our value of dependent variable, right? And here you can see that we here have 100 data points, and we have plotted it on a scatter plot. So what we have to do is we have to find a line that best fits our data. Now, what is the meaning of best fits our data? Let me grab a pen here. Okay, here is a pen. Okay, now here we can see that we can plot a line from here to here and here to here and right in the center of all this data point. Now, what best fit means that we have to put our regression line. This line is called a regression line, which is best fitting our data set. So we have to find a line that best fits our data. That means that our regression line must have list error from all of these other lines. You can see we will take two data points here. Let's say this one. So the okay, let me grab a pen here and black color. Okay, so the error for this line, sorry, the error from for this point is this much, and for this point is this much, and okay, for this point the error calculation for this line is this much, and this is this much. So we can clearly see that this error is way less than this error, right? So we have to find a data which sorry, a regression line that best fits our data. So we need to first calculate the cost, or we need to calculate the error in prediction. So here we are going to use the method called sum of squared error. Here let's take an example. Mm, let's say this is our regression line, or the line we plotted, and these are our data points. So we need to calculate this error, means the distance between this point and this line, and we just have to square it and add all of these data points to calculate our error. And let's take an example here. Suppose the actual selling price of the house is $220,000 and the predicted selling price is $195,000. So the error in prediction is $2,500. Okay, so now what we are doing here is we calculated the error as y actual minus y predicted, and we do this for all of our data sets, and then for our function we will calculate the square of this data, so that if our predicted data is more than our actual data, then we might get a negative value, so we have to square it to get the absolute value only. Okay, so here is how we are going to calculate our error, and we define our regression line as the line which gives us the least error. Okay, so now here are some guidelines for regression line. First is use regression lines when there is significant correlation to predict values. It means that we don't generally use regression line they generally don't fits our data set, right? It means that if we have a data set that are scattered on all of the coordinate plane, then we might be reluctant to use a single regression line, right? And stay within the range of the data. Do not extrapolate. For example, if the data is from 10 to 60, then do not try to predict the value of 500. That is pretty simple, I think. And third one is don't make prediction for a population based on another population's regression line. That is pretty simple, I think. Okay. So now what are the use cases of linear regression? There are many use cases, but here are a few examples. First is height and weight, alcohol consumption, and blood alcohol content. vital lung capacity and pack years of smoking, driving speed and gas mileage. Okay, so now we will have a look at different methods to calculate the slope and intercept, or the regression line to best fit our data. Okay, so the first method here we have is the regression line through brute force attack. Okay, so let's have a look at it. Okay, so here we are. Now let's have a look at it. So what is the least square property? To form the distance y minus y dash between each data point xy, the potential regression line y dash equals to mx plus b, and each of this difference is known as a residual. Square this residual and sum them. The resulting sum is called residual sum of squares, or SSRES. The line that best fits has the least possible value of SSRES. Okay, so let's take an example and we can understand better. Let's say our data set have x and y points that are 3, 1, 5, 6 and 7, 8, and our y dash is called y predicted equals to y equals to mx plus b. So here we have m and x is 3, so 3m plus b, and we can calculate the error for that as y minus y dash, so 1 minus 3m minus b. Okay, we did the same for the rest of the data. Okay, so now what we have to do is to square this error. Okay, so we all know that the square of a plus b plus c equals to a square plus b square plus c square plus 2ab plus 2bc plus 2ac. So finding the squared value for all of this, we will get this. This is pretty simple. And now we have to add all of this data like we saw in this. Okay, let me just, okay, right, we have to first find the square of the data and then we have to add it. Okay, so here we find the square of the data and then add it. Okay, so now what we want to do is find the value of slope and intercept from here. Okay, so whenever we have a equation like this, ax square plus bx plus c, we know the vertex of the curve is x equals to minus b upon 2a. So here what we can do is we can arrange our equation like this, and from here we can find the data of our intercept, or b, like b equals to 30 minus 30m divided by 6. Why we did this? Because in our equation we have a formula that x equals to minus b divided by 2a. So here minus b equals to minus 30m plus 30, that is 30 minus 30m divided by 2a, means here a equals to 3, so 2a equals to 6. So we can get this equation, and we need to rearrange our this equation to form it in form of m, and we will get a second equation as 30b plus 166m equals to 178. Okay, now we can solve these two equations very easily, and you can get the value of m equals to 1.75 and b equals to minus 3.75. Okay, so our equation is y equals to 1.75x minus 3.75. Okay, so now let's plot our data on the scatter plot, and here are our plotted data, and this is the regression line that has the least error for our data set. That was very easy, right? But what if we have a million data points like this? We cannot actually calculate this values like this, right, by hand. We did all this by our hand, but it will take a lot more time to calculate such values and proceed further. So there is a solution to this problem. So here we will use some for loops and some coefficient values like a slope and intercept to find our equation of line. So let's have a look at it. So here is the main function that we are going to use to find the slope and intercept for the data points. This is the slope and intercept of our data that best fits our data. Alright, so here you can see there are various variables in here, and we already don't know where this value is coming from. Right, we already defined it here like s underscore yi xi equals to yi into xi dot sum, but we don't know why we are doing this, right? So we need to know why we have to calculate this sum and calculate this yi underscore xi underscore byn and all such values like this. Alright, so let's have a look at it. Here is the linear regression complete derivation, and let's get started. And to understand it better, it is good that you might have a knowledge of partial derivative or summation. So let's have a look at it. Okay, so here we have n inputs and n outputs. We name it xi and yi, and we will define our best fit line as yi hat equals to a plus b xi. And now we need to minimize the error function that we named s, that is yi minus yi hat square. Yi is the actual value of our data set and yi hat is the predicted value of our data set, and then we need to square it because we don't want negative values and calculate it. Okay, so we have to square it, and we do it for all of our points. Now we will substitute the yi hat equation that is here, y equals to a plus bxi, in this equation, third equation. So we will get y minus a minus bxi square. Okay, so now we need to find the partial derivative of a line a, sorry, partial derivative of our equation s with respect to a. And why do we need to find the partial derivative? Because to minimize our error function s, we must find where the first derivative of s is equals to 0 with respect to a and b, because we need to know at which point our regression line, sorry, at which point our data has minimized error with the regression line. That's why we need to find the partial derivative, and in this derivation we will see that we have to put this equals to 0 because ideally we want 0 errors in our data set. Okay, so let's have a look at it. So we have to find the partial derivative for our squared error, that is this one. So now let's define yi minus a minus bxi equals to u. So this one is u. So where s equals to sigma for I equals to 1 to n and u square. So now we have our chain reaction equation with it, that is delta s divided by delta a equals to delta s divided by delta u into delta u divided by delta a. So first we find the partial derivative of s with respect to u, then we will find the partial derivative of u with respect to s. Okay, so the partial derivative of s with respect to u will be 2u, and the partial derivative of u with respect to a will be minus 1. Okay, while this is minus 1 because let's have a look at here. Our u is this one, and yi and a are the, sorry, yi and bxi are the constants here, but the derivation of a with respect to a will be 1, but here is the minus sign, so we have to keep it as minus 1. All right, so let's simplify it, and we will get minus 2 and sigma function and u. So we can write it as here, minus 2 sigma I equals to 1 to n, and our u is defined as yi minus a minus bxi as we defined here. Okay, here it is. Okay, now moving forward, to minimize the error we ideally take this value as 0. So 0 equals to this equation. Okay, now we have to divide by 2 from both the sides, so we will get 0 equals to the remaining of this equation. Okay, now what we do here is we divide this function into 3 different parts, like sigma for yi, sigma for a, and sigma for bxi. Okay, now we know that this sigma function for a for I equals to 1 to n will be na, because here is what it means, that a is repeated n times. So if we repeat a n times, then its sum will be n times a. So here we will put na here, and okay. So now what we need to find is the value of a. So we can take this na to this side and calculate the value of a. Okay, so now what is the value of sigma I equals to 1 to n yi, means sum of all the values in y divided by n, means when we divide the sum by total number of values, what we get the mean of the data. So we can write this as y bar, and we can write this as x bar, because sigma I equals to 1 to n xi divided by n will be the mean of data of x. All right, so this is our equation for a. Okay, now what we need to do is find the same for b. So here we will partial derive our s function with b. Here is the same thing we did. And okay, here we need to find the derivation of u with respect to b. Okay, so here what are the constant values? The constant values are yi, a, and xi. So sorry, yes, yi, a, and xi. So derivation of yi with respect to b will be 0, and derivation of a with respect to b will be 0. But the derivation of minus bxi with respect to b will be minus x, because derivation of b divided by derivation of b will be equals to 1. So the remaining value is only x. So let's simplify it, and we can say that we have minus 2 into sigma I equals to 1 to n xi into the function of u. Okay, now we will do the same thing as we did for finding a. So here it is, 0 equals to summation for I equals to 1 to n for xi into u function. Now multiplying this xi value for all of these points. Okay, now what we will do is we find the value of a in the last derivation. Here is the value of a, which is y bar minus bx bar. So we will substitute the value of a as y bar minus bx bar in our equation. So here we did it, and moving forward, and we need to just multiply it, and here we have. Okay, now what we will do is we will arrange the data in two different summations. Okay, so now our ultimate goal is to find the value of b, so we have to keep common the value of b here. Okay, so from further simplifying, we can get this b equals to this value divided by this value. Okay, this is pretty simple to understand. And if we simplify the formula, we can say that the y bar means the mean of y equals to yi divided by n, and same for x. Okay, so we can substitute the values here, so we can get n equals, we can get n into sigma xy minus sigma x into sigma y divided by n times sigma x squared minus sigma x squared. That is pretty simple to understand. We just put the value of y bar and x bar here, and we can do the same for the value of a. So here we have the final equations for our data, that is b equals to this one and a equals to this one, and our predicted function y I hat equals to a plus bx, and now we have the data value for a and b also. Okay, so now I think this is clear to you, and now we'll move on to the coding part. And keep in mind that we are not going to use the Scikit-Learn library to run our Python program, but we will just use the formula for slope and intercept that we just derived here. Okay, so let's move forward. Okay, so here is our code, and we will run it step by step. First, we are going to import the required libraries, that are NumPy, Pandas, and Matplotlib for visualization of our data. Okay, let's run it. And okay, we just have to wait. Okay, here we are. Now what we are going to do is we are going to load our CSV file in this variable called data, and then we will print 5 of its rows. So here are. Okay, now we want to see what are the number of columns available in our data set. So the number of columns are model year, make, model, vehicle class, engine size, cylinder, transmission, fuel type, and many more. Okay, now we just want to know if any of our data values like okay, this one, if any of our data values are null or missing, so we will check it by this data.info. Okay, so here we can see that the column of model here has none of the data points as null. So okay, we can move forward and you can see the data type of each column also. Okay, now we need to find, or if we want to know the statistical data about our data set, then we can just describe it. So here we have the count, mean, standard deviation, minimum value, 25% of, sorry, 25 percentile of our data, and the maximum, and all of this. Okay, so now our goal is to find the value of the CO2 emissions from all of this data. So now what we will do is we will plot our data and find that which means I mean to say that which of this column has most can be most useful to plot a regression line. Okay, so here is that here are the values. Okay, engine size, cylinder, fuel consumption, and CO2 emissions. So we need to predict our CO2 emissions from any one of this data because we are using just simple linear regression. In multiple linear regression, we can use more than one columns to find a dependent variable. Okay, so now let's plot a histogram for all four of this data. So here we have the plotted histograms. Okay, so what this means is for CO2 emissions 200 and for all the range 100 to I think 500 we have this much amount of count means okay, let's say for cylinder of 4 we have 400 cars, that is cylinder 4, and with cylinder 6 we have 350 cars, and so on. For all of this data we can plot this. Okay, now we are going to plot uh, we are going to take two columns at a time and plot it on a scatter plot, and we will decide that from which of these columns we can plot a regression line. Okay, so here I'm running all three of this. Okay, so here we can see that in the first plotting we took cylinders versus CO2 emissions, and we can see that here is our data, and for fuel consumption versus CO2 emissions here are our data, and for engine size versus CO2 emissions here we can see that our data is more likely to have a regression line, or we can easily plot a regression line like this in our data. Okay, so we are going to use engine size versus CO2 emissions for it. Okay, so this means that our prediction of CO2 emissions will be entirely based on our engine size of our car. Okay, so let's take a look at it. Okay, so for this we are going to take training data and testing data because we need to train our model to test our data sets. So here I'm going to take 80% of the data for training and 20% of the data for testing. So here I took length of data and to 0.8 and converted into integer, and from 0 to this much I mean 80% of the data it will consumed by training, and for testing I'm going to take this number to the end of the data. Okay, so let's have a look at it. So total data is 167 rows, and we will take 853 of them as training data and 214 as testing data. So now here is our main function that we are going to use to calculate slope and intercept. Okay, so have a look at this. Our slope is s underscore yixi minus yi underscore xi minus byn divided by this value. So now have a look at this, what this values or what this variables actually means. Now s underscore yixi means yi into xi dot sum. Okay, so now have a look at this. Okay, so here we are calculating the value of our slope, that has yi into xi dot sum. So here it is, yi into xi, and this is a summation sign. And after that we have yi xi divided by b by n, means yi dot sum into xi dot sum divided by n. So here what is means yi means, here y bar means the mean of our y data. So we did is we sum our y data value and multiplied it with x data values and divided it by n to find the value of y bar. Alright, so let's get ahead, and here we can see that s underscore xi, that means xi into xi dot sum. So here is x1 square, and xi underscore xi dot underscore b by n means xi dot sum into xi dot sum divided by n, x bar into xi divided by n. That is, I think, simple to understand. Now we have our slope value and intercept, means we can find the intercept from this line like we did here. Let me, okay, y equals to mx plus b. Now we want to find the value of b, so we can y minus mx. Okay, so this is y mean minus m means slope into x mean. All right, so here is what is it, y bar means y mean minus b times x bar. All right, and it will return slope and intercept. Now what we want to do is we want to check our function that it really works or not. So we are going to take dummy input and dummy output for a straight line, and let's find the slope and intercept for it. So it is 1 and 0, so that is pretty accurate because the points will be 1 1 2 2 3 3 and so on. So it's working. So now plot it on a graph also, so we can visualize it. I think it's going to take some time. Okay, I don't know what happened, but it's still taking some time. Okay. I don't know what happened, but don't worry, we will take a look at here. Okay, here it is. Okay, let me run all of this data, and we already know this and this and this and this also and this also, and dummy input, dummy output, and let's plot. Okay, here we are. Okay, so we can see that the intercept will be 0 and the slope will be 1. Okay, so now moving ahead, so we will now going to actually find the slope and intercept for our actual data. So we can see that it is 38 and 127, and now let's plot our regression line. So we can see that our regression line is right in the middle of our data points, so we can easily find that we can easily see that our error will be minimum because it's in the middle of the data points. Okay, so here is what I did is I took the x value, and this is the mx plus the b function, that is y equals to mx plus b. So instead of y we took m into x plus b and plotted a regression line. Okay, now we want to predict our data. So this is the function. So predicted value equals to y equals to mx plus b. That's simple, and it will return as the predicted value. It takes into input feature, slope, and intercept of a line. So let's say my engine size is 5.2. So the estimated emission will be 328. Okay, let's have a look at it. For 5.2, I can say, okay, yes, it's working right. It is 328. So Now we can predict for all of our testing data also. So here are the data, and these are, you can easily understand it. Minimum max equals to minimum of engine size, and actually I'm doing this for plotting this. Okay, let me. Okay, here we are. Okay, okay. I think we don't need to do this right now. Okay, all right. So here is our line, and now what we want to do is predict the engine size from our CO2 emissions. That's pretty simple. And we have as input our CO2 emission, and we have our engine estimated size is 3.16 that I don't think is possible, but this will take into account the fraction value also. Now what we want to do is calculate the error for it. So here we are going to take the RSS error method that will predict a value for our dataset, like a slope into input feature plus intercept, and residual equals to output minus prediction or predicted value, and then it is going to square it and it will return it. So here we can see that our RSS value is around 159,000 or 160,000. Okay, now what we want to do is print or plot our data and check how much different it is from our predicted value or our actual data. So here are our actual and predicted data. So here I think we can plot a graph for it. Yes, here we are. So this is our, the blue line is our actual data and the orange is predicted data. We can see that it is nearly accurate to it. Okay, so that's it for our video, and in the next video we are going to see what are the different kinds of methods we can use to calculate error, and how we can implement this all of this regression line function using Scikit-Learn library. That will not take more than 15 or 20 lines of code. So that's it for this video. Thank you so much for watching, and if you like this video, please hit the like button, and I will see you guys in the next video. Thank you so much for watching. And one more thing, that if you want to read all these articles, they are all available on my blog, and I will put the link in the description. And if you guys want the handwritten notes of this derivation, then you can comment your mail ID and I will send it to you. Okay, so thank you so much for watching this video, and I will see you guys in the next video.